Good morning, good afternoon, good evening, depending on when you're watching this. It's your boy Mr. Malachi, and I'm back with another video. And this video is on linear equations. So, what are linear equations? Linear equations are just these equations that have a single value or single solution, right? And yeah, we just need to know how to solve them, and really the trick is very simple. So let me give you an example, and let's look at how do we solve these. So if you have an x plus a 3 is equal to a 5, what you would have learned in grade 9 is the way you solve these is to get rid of this plus 3, you would subtract by 3 on both sides. So you try and isolate your variable by subtracting by 3 there, and you'd have your 5 there, and you're subtracting by the 3 there as well. So you do minus 3 on both sides. That would cancel these 3's, and so x would be equal to a 5 minus 3, and that is just easily a 2. So that's what you would have done in grade 8 and 9, subtracting on both sides and adding on both sides to get rid of that constant that's adding the variable. But what I want to implore you to do at this level is take another equation. All right. So let's take this equation and let's solve it, but instead of subtracting by 4 on both sides and adding by 6 on both sides, instead let's drag these numbers over. So I'm going to drag the 4 to the left and to the right hand side, and I'm going to take this 3x and I'm going to drag it to the left hand side. And what I need to remember is this golden rule that if something which means a term, if something goes over the equal to sign, the sign needs to change. So that's the golden rule about solving equations. When something goes over the equal to sign, the sign of the term needs to change. So how do I represent this? I will keep my 2x because it stays on that side. The 3x comes and joins it and becomes a plus 3x. It was a negative there, it will become a plus. Then I write the negative 6 that's already on that side, and this 4 is going over and it's joining it, and it becomes a negative 4. Then I do my like terms. 2 plus the 3 gives me a 5x, and if you subtract these you get a negative 10, and as your final step you divide by 5. Where am I getting that 5? This coefficient of the x. You always divide by the coefficient of the x on both sides, and this 5's are going to cancel, and so x is equal to a negative 2. So that's your final answer. I hope it makes sense. Yeah, you just need to basically remember this golden rule here and just apply it very, very precisely. All right, let's do number 3. All right, so number 3 looks like this. We have brackets in there. What we need to do is we just need to get rid of those brackets. And the only way to get rid of those brackets is to distribute this negative 3 into that bracket there. So the negative 3 is going to times the x, and it's going to times the positive 3. So I'll keep everything the same. 2x plus your 3. You leave the 2 and you distribute the negative 3. So negative 3 times x is a negative 3x. Negative 3 times that positive 3 is a negative 9. Then at this point you would collect your like terms. I'll bring all the variables that side, and I'll bring all the constants this side. So what I'll end up having is a 2x plus a 3x. I did not forget to change my sign. It was a negative 3x. It is now a positive 3x. And this side I have a 2 minus a 9, and I'm subtracting a 3. Again, it was a positive 3. It's a negative 3 now. Then I just add these. I get a 5x. 2 minus a 9 is a minus 7. Then I'm subtracting that. I get a negative 10. Right? Then at this point, I just divide both sides by 5. And so x is actually negative 2. And there we go. So that is number 3. Let's look at another example. Alrighty. So we have another example in front of us. I implore you to pause the video and try it yourself, and you can always mark yourself at the end. But yeah, what you're going to do in this case, you're going to take this 5 and you're going to distribute it into the first bracket. This negative 2 is going to distribute into the second bracket, and you're going to keep your negative 10x on that side. So let's do that. I'll get a 5, and for the second term I get a negative 15x. Negative 2 with the positive 10 is a negative 20 with the positive 2x, and this is all equal to a negative 10x. So what I'm going to choose to do this time is I'm going to take the variables to the left hand side, and that's what I'm basically doing. I'm taking them to the right hand side, excuse me. So I end up with a 5 minus a 20 on this side. Then on this side I have a negative 10 that is being added by a 15x, the sign changed, that is being subtracted by a negative 2. These subtract to give me a negative 15. That plus that is a positive 5, minus that is a minus 3x. Then at this point, I just divide by a negative 3 on both sides. Wait, is that a minus 3? No, it's not a minus 3, sorry. My bad. This should be a positive 3. Because again, this minus that gives, plus that gives me a 5. And a 5 minus a 2 is just a positive 3x. Then I divide by 3, I divide by 3, and so x is equal to a negative 5. And there we go. Very easy, as long as you're applying that step or that rule that says if you take something over, you have to change the sign. Let's look at 2 more. And what you would have seen so far is that when we're solving these, we are always getting one singular value at the end. Let's look at another case where we might not be getting that answer at the end. Alrighty, let's try this next example. We're given this equation here and we are asked obviously to solve for the unknown variable. So what we do is we would keep this 3x minus 1 the same, keep the 5, and distribute your positive 3. And you'd get a 3x with a minus 6. Then at this point, I'll drag all my variables onto the left hand side. So 3x will be subtracted by a 3x. Drag all my constants onto the right hand side, and I'll get 5 minus 6 with a positive 1. And at this point, I would subtract the 3x and the 3x. And if you do that, these actually cancel. So they don't give you 1x, they give you an actual 0. 3 minus 3 is just a 0. Then a 5 minus a 6 plus a 1 would also actually give you a 0. So what do we call this? Where your variable cancels and you're getting 0 is equal to 0. We call this an infinitely many solutions equation. Infinitely many solution. Yeah. And what that means is it does not matter what value of x that you substitute in there or in here, as long as it's the same value, we'll always make this equation true. Again, I repeat, does not matter. You could put in a 2 or make it true. You can put in a half, will still be true. You can put in root of 2, does not matter what value you actually put in there. It will always make this equation true. So we call these infinitely many solutions equations. So let's do one more. Alrighty, let's do this last example. So again, we're given this equation that says x or 6 open bracket x plus 3 is equal to 3 open bracket 2x minus 5. Again, we need to distribute the 6 into that bracket, which will give me a 6x plus an 18. We distribute the 3 into this bracket, which will give me a 6x minus 15. So now I'll bring my variables onto one side, which will give me a 6x minus a 6x. Again, it was a positive. It is now a negative. Then this is a negative 15. That is subtracting an 18. Then again, your variable cancels. You get a 0 there. But this gives me a negative 33. So what does this mean in this case? So we've looked at the one where 0 is equal to 0, but the one where you're getting a 0 is equal to a number. Then we call this a no solution equation. Again, it means there is no solution that you can actually substitute for x there that will ever make this equation true. So again, you need to understand that there is the ones where you solve them and you're getting a singular solution. You need to understand that there's the ones where you're solving them and you're getting infinitely many solutions. And you need to understand that there's these ones where you're solving them and you're getting a 0 is equal to a number of which this can never be true. It's actually false. And then you need to conclude that this is a no solution equation. So on that note, I hope this explains this work. And yeah, I hope you can practice and actually understand this. Bye.